In this video we are going to see how we can read and write data or use data logging with microSD card with Arduino. To show you how to log the data or save data from Arduino, from sensor, from voltage, whatever you have on microSD card, CSV Excel file, so you can plot it on your computer or process it for other purposes. And here's the schematic for this microSD card, and here is the library for SD. And here is the wiring diagram. I pins the right one, use it. It will start reading it. Hi, welcome to an Arduino step-by-step course by RoboJax. In many applications, you will need to read and write data from Arduino. For example, you are reading temperature, you're reading speed, motion, position of something, whatever you have, you want to write it and keep the record. So data logging or writing the information. You can write it as a CSV format, so you can open it, and also in Excel, which I'm going to show you. And in this case, I'm going to show you how to write a simple example from Arduino. You don't need to install any library or anything, because once you open Arduino IDE program, it comes already bundled with the SPI. This works with SPI communication. It needs 2 wires to power up. This is a 3.3 volts chip, but there is a 5 volts converter, so it can work with 5 volts, and this is just a logic level converter. There is no other component. So this module directly works if you wire it properly. And here are the pins, which have been all labeled clearly. And these are SPI connection pins. So these 2 pins is used for powering up, and then 4 other wires. Very simple. We are using SPI communication to read and write. So 2 wires are used for powering, and then we have 4 wires for SPI. And these pins cannot change. These are fixed SPI pins for this. For different Arduino, we have different pins as SPI, which are very easy, available over the internet, so you can use it with Arduino Mega, Nano, whatever you have. Here is the explanation of Serial Peripheral Interface, or SPI, from Arduino documentation page. The pins are as labeled. This is called old, master, and slave. Master in, slave out, MISO, and master out, slave in, MOSI, and then slave select pin, or SS. Now they use now controller or peripheral, which is new. So for this we will have controller in, peripheral out, CIPO, peripheral out, and this is controller out, peripheral in, and CS is called chip select pin. And you can see this is for sending data, control in, peripheral out, and this is sending data to the peripheral. But make sure for the CS pin, on each device that controller uses to enable and disable a specific device. When a device chip select pin is low, it communicates with controller. When it is high, it ignores the controller. This allows to have multiple SPI devices sharing the same CPIO, COPI, and clock lines, CLK. So this is just for selecting those different SPIs if needed. And here's the schematic. This is the microSD card where you insert the SD card, microSD card. We have a voltage regulator, where we get the 5 volts from VCC. It converts it to 3.3. This is the AMS 1115 3.3. This is the 3.3 volts version regulator. And then we have some buffer gates that has been used as a logic level converter. So if this is used with 3.3 volts, we don't need it. We can just connect it directly. And here are the pins. We have CS pin, and then clock, MOSI, MISO, VCC, and ground. Very simple. I will provide you the link if you need this. Now let me insert the micro SD card. Here's the micro SD card that I've inserted. It's 32 gigabytes. Let's right click and check properties. This is very important to have it formatted as FAT32. If you have not done it, we can right click and select format and make sure that you are getting here FAT32 and then start. So this will be formatted as FAT32. And here is the library for SD. It has so much features that I cannot cover everything, but let me go through this so you can see it. So the library supports FAT32 and FAT16 and FAT32. So the name convention is 8.3, which means maximum character for the file name should be 8, and extension must be 3. So we can use file name with a directory or folder. It already comes with these example card info, which gives you the information for the card, data logger, which reads up to 3 sensors, and dump file, it reads the file, it creates and destroys the file, it prints list of files on the micro SD card, and this reads and writes, which I'm going to show you some of them. And here are the classes that we have. We have begin, exists, which can check the file, and then exists, make directory, you can create a directory, open, remove. This is removing the file, and then remove the directory. So we have make directory, mkdir, and rmdir. That's for SD. For the file class, we can do all this: name, variable, close, flash. When you put peek, position, print, seek, so we can go to different portion, is directory, rewind directory. Let's see for the seek. So we can go to any position in the file, must be between the 0 and the size of the file, inclusive, whatever is the file size. And here is the wiring diagram. I used the software Fritzing. This is a free software. From the top, this pin is connected to ground. The second pin is VCC. It is connected to 5 volts. And then we have the third pin, which is orange. The orange is MISO. It is connected to pin 12. And then yellow is MOSI. And the last pin, and then we have green. Green is connected to pin 13. And the last pin is connected to pin 4. And here is the actual wiring, ground. The last pin is connected to ground of Arduino. Then green, the red is connected to 5 volts. And here orange is connected to pin 12, yellow is connected to pin 11, green is connected to pin 13, and blue is connected to pin 4. Let me explain the code. you will click on File, Examples, and scroll down, and you will see SD. There are so many available sketches or code available for you. The first one is reading the card, the SD card information. The second one is a data logger, where it reads 3 analog pins and reads the voltage, potentiometer, whatever you connected. The dump file will read the content of the file and print it on the screen. Files, this will allow you to learn to remove a file. The list file will print the list of all files on microSD card. The non-blocking write is a program that if the microSD card is busy, it saves the data on a string and waits and tries it every 10 milliseconds. And read and write is the most basic one, which we need. So we will be able to write something into SD card and read it in the same sketch. So if I click on read and write, this is the code that comes. So let me explain it. The file is called read write. So it first includes SPI library and then SD. These two are needed. You don't need to install or download anything. They are all included. After that, we are creating from the file, we are creating an instance of the file. It's called my file. So we will work with this object inside the setup. This is for serial monitor to print information for us. And this is just checking if serial monitor is not working. It will just stay there forever. This will just print this on the screen, and if SD began is not true, so this is the most important one. We say sd.open, so this opens or creates this file. When you put this constant here, file write, it will write to this file. Even if the file does not exist, it will create it, so you don't worry about it. F my file, so this my file object is now holding the information and name for this file and reference. So if this is true, then this is printing text on the screen, writing a text, and this is writing in the file. So here is what we have done. My file.println, print line, and this is the text, and that's the ending. And once, so if you want to write more lines, just copy and paste and put here whatever, something else. Okay, so this will be written on the file, and as many as you want. If you want, you can write a loop, so you can write multiple lines automatically, which I'm going to show you to. And then once you're done, you write my file.close, so you can close it. And after that, this is just printing on the screen, done on the serial monitor. Else, if this my file is not true, then it will say error opening text file. Now to open the file for reading, we use sd.open. This time we just type the file name and we don't put any other constant, for example like this. But keep in mind that if the file doesn't exist, it will fail. So the file name must be there with the same exact name. So here we check again if the object is okay. Then this while means until my file available, until the contents are there, then go one by one. So what it does is it gets it serial.write my file read. So once we reach at the end, this will be not true and the while loop will exit. If you want to learn about while loop and loops, I have separate tutorial, and the link will be below this video or just on the top of the screen right now. Click to go there. After you're done reading, close it. Else, if there is an error, it will print this text for us. And that's done. Because this needs to be done only once, the code is inside the setup. So this will run only once, and as you can see, inside the loop, we have nothing. Now, let me upload the code and run it. It's 32 gigabyte. I'm inserting it. There's no light or anything. Make sure the wires are all connected. Let's upload the code to Arduino. So the code have been written and it's done. So to read it, we are just opening the serial monitor by clicking in here, or you can go to Tools, Serial Monitor, or press Ctrl-Shift-M, whichever you prefer. Now this is just reading. So the code have been written multiple times. If you do not read this text at the bottom, this should be 9600. If you select a wrong value, then this will not read it for you. So you see, it will be like this. Now I have to make sure it's 9600. And as you can see, it has been written multiple times. Every time you open the serial monitor, it initializes the setup, and so it runs the code from the beginning. Let me now insert the microSD card and wait for it. So this is available now, and here is our file. Let's just open it, and here are all the contents that are inside the file. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. And in this project now, we are going to read the voltage from potentiometer. As you rotate it, it will be recorded on this microSD card, and on the same time, if you want it, it will be displayed on the screen. But I've added a push button here, so when you press it, the content of this microSD card will be read and will be displayed on the serial monitor. And here is the wiring for the potentiometer or variable resistor. It has 3 wires. The one side is connected to ground, the other side is connected to 3.3 volts, because we have only one 3.3 volts here. Here we have also 5 volts, but I didn't bother. The middle pin, it's very important, do not connect the middle to ground or VCC. The middle is connected to analog 0, and we are reading the voltage from this pin. And here, the way I've shown you the 3 pins, the right one is connected to ground, the left one is connected to 3.3 volts, and the middle one, I'm connecting it to analog 0. Here is the wiring for the push button. Everything else is the same. We have added this push button. One wire is connected to pin 9. The other wire is connected to ground. The rest is the same as before. And here is the code that I've written for the push button and serial monitor with SD card. We are defining this variable for push button for serial monitor, because if you don't need it continuously to print on the serial monitor, then set this to false, because it consumes resources, and in the long run Arduino might crash if you leave it few days, for example. And then this is a log file of type character. This is string. We are putting our text here, whatever file name you want, but must be less than maximum of 8 characters. And this is a read push button pin. I've defined pin 9. Change it if you want to use other pins. And these are write log and read log are functions that are at the bottom of the code, and here we use them as prototype, so Arduino knows these functions are available and it will not give error. The setup is the same. This line I've added to define the push button pin, which is pin 9, as an input, and I use pull up to avoid using resistor with a push button. And if you want to know why we need resistor, I've given an example here on this screen. You will see the pop-up, or the link is below the video. Watch that video. This line is removing the file if you want to remove it, if it exists. Otherwise, if you don't want to remove it, just comment this out and it will not remove it. But I prefer for new project always to remove the old data. And this line is just creating the object for the log file, whatever you have. This is exactly as before. Now, this line is reading the analog 0. We have connected the potentiometer, and this line is converting the sensor value, which is from 0 to 1023. And on my Arduino Uno is 5 volts, so I put here 5. If your Arduino is 3.3 volts, put here 3.3, so you can get correct value. We are getting the voltage, and here we check if the push button is equal low, which means if it is pressed, then after 100 millisecond delay, run this read log, which I'm going to explain it. Otherwise, write log continuously. So inside the write log, we are using the same object now, and then writing this text inside the file, because we have double quotation. After that, we are writing the time. Because this is time, we are getting the millis. Millis is a time from the moment you turn on Arduino. It starts in terms of millisecond, or 1,000th of the second. Because it's a huge number, we are dividing it by 1,000 to get the second. And this line is adding a tab, \t mean a tab character or tab space. And then we print this text. And after that, we print the actual voltage that comes here. And then at the end we add V, so it looks like voltage. But here, if serial monitor is set to true, we get the time, voltage, and then we close it. And after that, on the screen we say done after each writing. So read log, here we get the object. If my file exists, then we print on the screen the file name, and then while my file dot available, the content is available, we write this using my file dot read. This is getting the value, and this is writing it on the serial monitor, and then we close it. If my file does not exist, we get error opening and this file name. Now, opening the serial monitor, let's just press reset, so everything is resetted. Arduino starts from the beginning. Now this is the voltage that we are reading, and if I rotate the potentiometer, you will see that we are getting maximum of 3.3 volts. And here, and if I reduce it, it goes to 0 volts. Now, if I press this push button, now it will start reading it. All the values that we have up to 8 seconds, 9 seconds, and now the time is 11 seconds. This is a new one. This is not reading. But if I hold it for 100 milliseconds to read. So this is the reading up to maybe 25 or something, whatever was written. So this is just reading. Now let's open another example. File, examples, SD, card info. So this is the code that reads the information about the card. And we don't have to worry what it does, just upload it. Okay, so here it says SDHC, the card type, the cluster, the block, and total blocks, and the volume the format. So this is in terms of kilobyte, megabyte, and gigabyte. Files on the system, test.txt, Amazon 1 file. I have deleted it, but it's still found it. If I click on File, Example, SD card, List Files, this will give you the list of all files in your micro SD card. Let me explain it. So we have an object called root. We open the root. When you put /, that means the root of the micro SD card without going inside any directory. So now this is an object called root. We use print directory and pass this root to print it. Now let's see what this is. This is a function in here. Print directory, it receives the file object. This is just number of tabs. This 0 is number of tabs, and here the print directory will receive the object for the file and then the number of tabs. While true, this means forever, just go and read it. So this will stay. And here directory dot open next file. It reads that directory that we have, and the next file is stored as an object here. It's called entry, and it checks it. If the entry is not valid or no file, it will break exit. Otherwise, this for loop goes by the number 0, 1, 2, 3 up to whatever you have, because now this is already 0. 0 is not bigger than 0, so this will not print any tab. And print entry, and entry.name, this will print the name of the file, and if this is directory, it will print something like this. Otherwise, it will print 2 tabs, and then print entry.size of the file, and close the file, Let's upload this, and let's open the serial monitor. So it opened test 1, test notebook 2, 3 pens, hello, and done. And here it says also one file, 180. The reason that we are reading 000 is because the files have nothing in them. Let me change this test 1 file. Let's create here a file called count. And it is 0, and let's open it and put something. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0, close it. So that's 10 characters. And let's just reset it so we can see now. And here, as you can, and here it shows 10, the length of the contents of this text file. And here is another example. If you go on File, Example, SD card, and non-blocking write, open it. This is the file. So what it does, if the file that you're trying to write and micro SD card and SD card is busy, then it will keep the data in a buffer, so you can later on write it until it is free. So first, the file name is stored in this variable, and then we have an object for the file. And here we are creating a string called buffer. So this variable is holding our text until it is written. This is just for checking every 10 milliseconds, remembering the last time. And here we create a buffer of 1 kilo, so that's 1024. Buffer, that's the same variable dot reserve, this much memory is allocated to this variable. We check every 10 milliseconds if something is added, so we remember the current time using millis in the variable called now, and now if now minus last time is greater than 10, then we add this text to buffer. This plus means add hello to whatever is inside buffer. Next line, the now, which is the time, into the buffer, and return a new line to the buffer. So this will add all this and create new line, and then last millis will remember the now time. This now time millis will be stored. And here text available for write, so we are checking it. If it is available for write, then the chunk size that is available will be in here. So that's very interesting, available for write. If the length of the text that we have and the chunk, both of these are greater than the chunk size, which is the available size, then we write. We will turn on, and here this line is, we are just writing the text string using C string. Don't worry about this, this is a buffer C string. This gets the value, and we also need the size to write it, and then LED was on and it will be turned off, and then we remove the buffer. Now I'm going to show you how to data log in CSV mode so you can view it on Excel. And here is the code. Let me explain it. We are defining a serial print. If you want to print it continuously as false or true. If you want to print it, set it to true, otherwise false, all lowercase, so it will not consume resources when you don't need it. And this is a file name, datalog.csv. This will make it easy for you to open it with Excel, and the same as before, it must not be longer than 8 characters, and the extension cannot be longer than 3. So we have push button like before. This is the interval of logging, how fast you want to log in millisecond. If you want to log it in every 10 milliseconds, just make it 10, or if you want to make it in every 3 seconds, make it 3000. So up to you. These two values are for calculation reason. Do not change or touch them. The rest is exactly the same. And here we're reading the analog pen. The value is from 0 to 1023. It will be an integer stored here. This line is calculating the voltage of 5 volts. Because of my Arduino is 5 volts, we are dividing 5 by 1023, and the result is multiplied, so you can get the actual voltage. And here, if the push button is pressed, we wait for 100 milliseconds and read the log, which I explained it in previous video. And here is the write log voltage. The voltage that we have is coming to this, the mouth of this function, which is write log, which I'm going to explain it. And here, that voltage comes here. This is just for debugging, and I put them as comments so we can see it. I'm going to delete it. We'll start from 0, 1, 2, 3, and for 1 second it will become 1000, and for 5 seconds it will become 5000. I have separate video explaining this. So here we are subtracting them from remember value. As time passes, this value increases, and this will be older. And then the difference, if it is greater than intervals that you set for 500 milliseconds or something, then everything that is inside up to here will happen. So we are creating an object for the file, and here we check if the header written is not written. So we put time and voltage at the top row. Once we wrote it, then we say header written is equal true, so next time for every other row it will not be written, so this is for that. This is saving the current millisecond time, putting comma, putting the voltage. This was also for my debugging. And if serial print is enabled at the top of the code, then it will print time, millisecond, voltage, text, and the voltage and V value on the screen. And after that we close the file, and also we print on the screen. If the serial print was enabled, also we say done, and then we remember the current millisecond time. So it will continue doing the same. Read log is the same as previous lesson. Let's upload the code. Let's open the serial monitor. Initialization failed. Card on my computer. Let me remove it and insert it in here. And let's reset Arduino. Now, if the serial monitor is not enabled or set to true, you will not be able to see it. So let's turn it on so you can see it. Upload again. Open the serial monitor, and here this is the time and the voltage. It's around this value. The wire is loose, so now we are reading stable voltage here. Let me rotate this, so around 3, and let's go back. So this is the voltage that we are recording in microSD card. Let me just remove it. So I'm going to show you. Here's microSD card, and here is the file datalog.csv. I'm double clicking and opening it in Excel. Excel will open it. While the data is selected, click Insert, come here and select the scattered chart. And here, this is the voltage. I rotate it. So these are the values that when I went to maximum, around 3 volts. Otherwise, we have created a log of reading the voltage. The same way you can do it for temperature, for speed, for distance, whatever you have, it will be done very easily. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from RoboJax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. And so 18 seconds. Now let's press it. So if I uncheck this and scroll this up to show you, because it went very quick. Reading